The Earth turns, but not the Earth we know. 150 million years ago, the planet's breath was heavy with heat and moisture. Skies glowed with the smoke of volcanoes, their plumes rising like black columns into an atmosphere thick with carbon. Thunderstorms rolled endlessly across vast, steaming plains. Forests of towering conifers and cycads stretched higher than cathedrals, their canopies swallowing the light, their roots drinking from rivers that wound like veins through the land. Beneath this living canopy, shadows stirred. Colossal reptiles, the rulers of their age, pressed their weight upon the soil with every step, their movements slow and deliberate, like mountains that had chosen to walk. Long-necked giants grazed the treetops, while predatory hunters lingered in their wake, watching, waiting. The air trembled not only with their footsteps, but with the chorus of insects, the calls of primitive birds, the rustle of creatures yet unnamed. But the Jurassic was more than the theater of giants. It was a planet in the midst of transformation. The single supercontinent of Pangaea, once unbroken and immense, was fracturing under the invisible pressure of Earth's restless crust. New oceans were being born, flooding lowlands with shallow seas, alive with ammonites and reptilian swimmers. The face of the Earth itself was tearing apart, sculpting coastlines and climates in ways that would define the continents to come. And yet, even as life flourished, mystery lingered. How did this strange stability endure for so long, allowing forests and reptiles to thrive for millions of years? What hidden balances of climate and chemistry made this world so alien, yet so fertile? The Earth we walk upon today is only the latest mask of a planet that has worn many faces. To ask what the Jurassic was like is not merely to study fossils, but to glimpse an ancient Earth, breathing, violent, and endlessly evolving. If the ancient past stirs your imagination, and you wish to journey deeper into Earth's forgotten ages, join us, subscribe, and walk with us through the mysteries written in stone. The story of the Jurassic does not begin with the dinosaurs themselves, but with the people who first uncovered their bones. Long before the term Jurassic was ever spoken, fragments of an ancient world were already rising from the cliffs, and quarries of Europe carried in the hands of those who sought stone, coal, and salt to fuel the growing engines of the industrial age. In the early 19th century, the southern coasts of England bore witness to a quiet revolution. Along the crumbling cliffs of Lyme Regis, a young woman named Mary Anning searched the rock face with patient eyes. She was no scholar, no wealthy patron of science, but the daughter of a carpenter, earning her living from the sea. Yet, in her hands, the earth began to surrender secrets older than human memory. In the shale and limestone, she uncovered the twisted skeletons of marine reptiles, creatures with eyes like lanterns and teeth like knives, ichthyosaurs and plesiosaurs, monsters that seemed to have been born of myth, but whose bones were all too real. Each fossil she found was more than a curiosity. It was a revelation. They hinted at a world that had once been utterly different, a world in which colossal reptiles had ruled both land and sea. Yet this idea stood in stark defiance of the beliefs of the age. The Earth, according to scripture and tradition, was only a few thousand years old. Life, it was thought, had always existed as it does today. But the stones whispered another truth. As word of Anning's discoveries spread, so too did the fascination. William Buckland, the eccentric Oxford geologist, was among the first to take these fossils seriously, puzzling over the remains of a vast reptile whose teeth suggested both ferocity and scale. He called it Megalosaurus, the great lizard. And though his reconstruction was clumsy, Imagining a squat, lumbering beast, the very name carried weight. It was the first recognition that Earth had once been home to a lineage of giants. The puzzle deepened when Gideon Mantell, a country doctor with a passion for fossils, unearthed the teeth of another strange reptile. Their shape resembled the enamel of modern iguanas, but grotesquely magnified in size. Mantell named it Iguanodon. This was no isolated creature, no freak of evolution preserved by chance. It was part of a lost kingdom of reptiles, creatures that once thrived in landscapes, long buried beneath stone, and yet the true age of these fossils was still a mystery. The layers of rock in which they were found seemed to suggest immense antiquity, but how old was immense? Some clung to the idea of catastrophes, great floods, or divine punishments as explanations for these vanished animals. Others, more daring, began to speak of deep time, an Earth not thousands, but millions of years old, its history layered like the pages of a book waiting to be read. It was in these very layers that the term Jurassic found its birth. Alexander von Humboldt, the great German naturalist, had studied the banded rocks of the Jura Mountains straddling France and Switzerland. Their strata revealed an era unlike our own, a sequence of limestone and marl that spoke of ancient seas and tropical climates. Humboldt gave the name Jurassic to this chapter of Earth's history, not yet knowing it would one day become synonymous with the age of dinosaurs. Geology itself was a new language in the 19th century, a way of seeing the Earth not as a static stage, but as a living manuscript written in stone. Each layer was a sentence, each fossil a word, each mineral a hint of the forces that had shaped continents and oceans. To trace these strata was to journey backwards in time, further than any human memory could reach. The Industrial Revolution unwittingly accelerated this journey. As railways expanded, as coal was dug from the earth in unprecedented volumes, miners and engineers stumbled upon fossil beds buried for eons. The hunger for fuel unearthed not only the blackened remains of ancient forests, but also the bones of creatures that defied imagination. Paleontology was born not in laboratories, but in quarries and mine shafts, in the dust and danger of an age that tore open the earth in search of progress. What emerged from these excavations was not a handful of isolated monsters, but a growing mosaic of a vanished ecosystem. There were herbivores of immense scale, carnivores with teeth the size of daggers, winged reptiles whose wings stretched wider than a man's outstretched arms. And there were plants, too, preserved in stone impressions, ferns and cycads, leaves that spoke of a greenhouse world, humid and lush. The realization was slow but inescapable. These were not curiosities, not anomalies. They were fragments of an entire world that had once flourished and then disappeared, a world buried beneath millions of years of silence. The question began to press upon the minds of scientists and philosophers alike. What was this lost world like? Could it be imagined not merely from bones and teeth, but as a living earth? Was it possible that entire ages had passed, each with its own landscapes, its own rulers, its own rise and fall? The Jurassic emerged from the rocks, not as a name, but as a challenge. It demanded a new vision of time, one that dwarfed human history and placed our species not at the center, but at the edge of a vast unfolding story. The discovery of the first fossils had opened a door. Beyond it lay an Earth that was strange, fertile, violent, and endlessly evolving, an Earth that asked to be remembered. The realization that these fossils spoke of another age struck the scientific world like a tremor. To gaze upon the bones of a creature that no longer walked the earth was to confront extinction itself, a concept once unthinkable. For centuries, the prevailing belief was that life was unchanging, that the forms seen in the present had existed since creation, immutable and eternal. But the silent testimony of stone said otherwise. The earth was older, stranger, and more violent than anyone had dared to imagine. Each discovery chipped away at humanity's cherished certainties, and in the cracks, a deeper vision of time began to take shape. The word dinosaur itself, terrible lizard, was not coined until 1842 by the British anatomist Richard Owen, who gathered together the remains of Megalosaurus, Iguanodon, and Hylaeosaurus into a new family of colossal reptiles. Yet even before the name, the idea of such creatures had captured imaginations. Newspapers described them with awe. Artists painted them with heavy scales and reptilian menace. And in the gardens of Crystal Palace, full-size models were erected to astonish the public. They were depicted as monstrous, ponderous beings, a reflection not of the creatures themselves, but of the human inability to comprehend life so far removed from the familiar. Still, the idea of a Jurassic Earth, ruled by giants, was now firmly embedded in the cultural mind. At the same time, geology was evolving from a curiosity into a science capable of measuring the abyss of time. Men like William Smith, mapping the strata of England, showed that rocks were not chaotic but layered in order, each stratum telling the story of a distinct epoch. Fossils, once seen as natural curios, became time markers, the signatures of vanished worlds. A seashell in stone was no longer just a shell. It was evidence that the land had once been sea. A fern pressed in coal was proof that a forest had once thrived where now stood industry. To walk through a quarry was to walk through chapters of Earth's forgotten history. The Industrial Revolution, with its insatiable appetite for fuel and stone, unknowingly became an ally to this new science. As tunnels were cut deeper, as canals were dredged, and as quarries expanded, the past was laid bare in ways it had never been before. Fossils emerged, not from the hands of scholars, but from the calloused palms of miners, fossil dealers, and amateur collectors. Entire skeletons were hauled from stone, their vastness shocking even those accustomed to the raw power of industrial machines. In coal beds, once living forests reappeared, their trunks petrified, their leaves imprinted like fragile signatures across slabs of rock. In limestone, the wings of dragonflies and the delicate feathers of early birds seemed frozen mid-motion. Captured by time itself, the naming of the Jurassic crystallized these discoveries into a coherent epoch. In the Jura Mountains, where Humboldt studied the banded cliffs, the rocks themselves bore testimony to a time when shallow seas covered the land. Layers of limestone told of warm waters, rich with marine life. Interbedded shales spoke of shifting environments, of tides and currents long stilled. The fossils that emerged from these rocks were not scattered anomalies, but part of a pattern, an entire ecosystem preserved across millions of years. From the mountains of Europe to the quarries of Britain, a picture began to form, fragmentary, incomplete, yet undeniable. The Jurassic was no myth. It was a real world, lost in time. For the thinkers of the 19th century, this realization was both thrilling and unsettling. If Earth had once been so utterly different, then history was not static but fluid. Landscapes could rise and vanish, species could flourish and then disappear forever. Even the continents themselves might not be fixed. Whispers of this idea were already forming, though it would take another century for the theory of plate tectonics to confirm that Pangaea had fractured during the Jurassic, giving birth to new oceans and climates. At the time, the thought alone that the Earth had shifted so profoundly was almost too vast to grasp. Yet the fossils kept speaking. They spoke of creatures that had no parallel in the present, long-necked sauropods whose vertebrae stretched like cathedral arches, carnivores with teeth honed for bone crushing, ammonites with shells coiled in perfect geometry, each chamber a fossilized equation of buoyancy and survival. They spoke of forests humid and dense, where cycads and conifers reigned, and where the first primitive birds took tentative flight above the heads of dinosaurs. Every new discovery was not just a specimen, but a glimpse, a window into an Earth as alien as another planet. The deeper question began to take hold. Were these monsters the lonely products of catastrophe, or the rulers of an entire coherent biosphere? Fossils were appearing not in isolation, but together, predator and prey, plant and pollinator, land and sea. Slowly, paleontology shifted from the reconstruction of individual skeletons to the reconstruction of entire ecosystems. The Jurassic was no longer just a collection of bones. It was a world, and the more it was revealed, the more humanity was forced to confront the humbling truth. Earth has been many worlds, and we inhabit only the latest, the discovery of creatures from the Jurassic arrived not only in the rocks, but in the minds of a society unprepared to receive them. Victorian England was an age of contradictions, a world driven by steam engines and scientific progress, yet still anchored to scripture and tradition. When the bones of colossal reptiles were first brought into public view, they seemed less like relics of natural history and more like intrusions from a forgotten mythology. Gigantic vertebrae, serrated teeth, and petrified skeletons were unlike anything seen in the modern world, and they demanded explanation. But the explanations available to the 19th century mind were fragile, built upon assumptions of a young Earth and a fixed creation. The fossils told another story, one that would challenge not only science, but faith, philosophy, and humanity's sense of place in time. The first public depictions of dinosaurs reflected this tension. Artists and naturalists, relying on fragmentary remains, imagined the creatures as swollen, reptilian hulks, slow, dim-witted monsters that dragged their tails across swamps and lay half submerged in stagnant waters. The reconstructions of Benjamin Waterhouse Hawkins at the Crystal Palace in 1854 gave physical form to these imaginings, casting the Jurassic as a theatre of sluggish giants. To the public, they were awe-inspiring, even terrifying, but also strangely grotesque alien beasts that seemed more like curiosities than living, breathing animals. Yet for all their inaccuracy, these models carried immense cultural power. They cemented the idea of an age of reptiles into the popular imagination, a vanished kingdom in which dinosaurs ruled supreme. The reality of active, dynamic creatures would only come later. But beneath the spectacle lay a deeper unease. If these fossils truly represented animals from another world, when had that world existed? The biblical chronology placed Earth at only a few thousand years old, a span that left no room for extinct empires of life. The concept of extinction itself was unsettling. Could God's creation really have included forms that were now gone forever? And if entire species could vanish, what assurance did humanity have of permanence? In sermons and in parlors, these questions stirred uneasily, forcing a confrontation between scientific discovery and theological tradition. The science of geology provided the tools to unravel the timeline. William Smith's stratigraphic maps had already shown that the Earth's surface was not chaotic, but layered in an ordered sequence, with fossils embedded like signatures in stone. Each layer represented an epoch, a window into a vanished environment. The Jurassic, with its limestones and clays rich in marine fossils, revealed itself as one such chapter, a time when warm seas covered Europe and reptiles thrived on land and in water. To trace these strata across the countryside was to walk backward into history, each step peeling away millions of years. The Victorian mind was forced to confront a radical truth. Earth's history was not measured in centuries, but in ages. The very notion of deep time was both liberating and terrifying. It expanded the horizon of human understanding beyond measure, yet at the same time it diminished humanity's centrality. If the Earth had existed for hundreds of millions of years, then human life occupied only the faintest sliver of its story, a fleeting shadow on an ancient stage. The Jurassic fossils, once curiosities in stone, became witnesses to this immensity. They testified to worlds that had risen and vanished long before the first humans walked the earth, worlds with their own climates, their own ecologies, their own dramas of survival and extinction. Speculation about that climate began to take form. Observers noted the lush plant fossils preserved in Jurassic rock, cycads, ferns, and towering conifers. These suggested a greenhouse Earth, warmer and wetter than the modern world, with no polar ice to bind the seas. The very presence of giant reptiles implied conditions that could support their immense bodies. Abundant vegetation, mild winters, and vast landscapes unbroken by glaciation. Though Victorian scientists lacked the tools of modern climate modeling, they began to sketch the outlines of a planet, unlike today, an Earth where tropical forests reached into high latitudes, and shallow seas spread across continents that are now landlocked for the public. Such visions blurred the line between science and imagination. The fossils carried a strange poetry. They conjured visions of jungles steaming under volcanic skies, of monstrous creatures stalking fern-filled valleys, of oceans alive with ammonites and marine reptiles. To some, these worlds seemed fantastical, almost dreamlike. To others, they were unsettling reminders that the Earth was not made for humankind, but was instead a restless planet that had worn many faces, each more alien than the last. The clash between science and religion deepened as the century advanced. The revelations of geology and paleontology coincided with Charles Darwin's theory of evolution by natural selection, a framework that explained not only extinction but transformation. The fossils of the Jurassic were not just relics of a lost world, but stepping stones in the great unfolding of life. They were evidence that species were not fixed, but mutable, shaped by pressures of survival, competition, and change. In Darwin's vision, the dinosaurs were not aberrations, but natural rulers of their age, just as mammals would later rise in their absence, to a society steeped in the belief of divine permanence. Such ideas were revolutionary. The Earth itself seemed to rebel against the neatness of biblical chronology. The rocks whispered of immensities beyond imagination. The fossils showed life evolving, flourishing, and vanishing long before humans arrived. The Jurassic became a symbol of this disquieting truth. It was not merely an age of reptiles, but an age that revealed the insignificance of human time against the vastness of planetary history. Yet there was also wonder. The first maps of Jurassic strata, the first museum halls filled with skeletal giants, the first books that described the Earth in epochs rather than centuries. All of these expanded the human imagination. The dinosaurs of the Jurassic were not just monsters. They were emissaries from deep time, reminders that the planet beneath our feet was alive long before us and will endure long after. In the silence of their bones, people began to hear the echoes of worlds lost, and in that silence, a profound philosophical reflection began to grow. The first scientific reactions to the Jurassic were therefore not simply about creatures in stone. They were about humanity's shifting place in the cosmos. Once thought to stand at the center of creation, people now confronted a far older Earth, one that had been home to empires of life beyond memory. The Jurassic was both a revelation and a warning that the Earth is a stage for many worlds, and ours is but one of them. Under the vaulted ceilings of Victorian museums, the presence of these ancient bones stirred both awe and unease. Visitors walked past towering skeletons whose shapes were reconstructed from fragments, their vast ribs and teeth assembled into forms that were as much imagination as fact. The scale alone was enough to unsettle. Here were creatures that dwarfed, horses that made elephants seem modest, that suggested a past in which the natural order was not aligned with the familiar. A haunting question lingered in the air. What kind of Earth could sustain such monsters? The polished floors of London's institutions could not mask the unsettling truth that these bones pointed to a planet fundamentally unlike the one people inhabited now. It was as though the Earth itself had been reborn in cycles, each incarnation carrying life forms incomprehensible to those that followed. As more fossils emerged from quarries, cliffs, and railway cuttings, the narrative of these creatures deepened. The Industrial Revolution, in its hunger for coal and stone, became an accidental accomplice to paleontology. Each tunnel carved, each mine shaft dug, revealed pages of Earth's history sealed away in rock. In those dark seams and sunlit exposures, fossils appeared like messages from another world, their patterns etched by pressures and minerals into enduring stone. But the revelations came piecemeal, bone by bone, and the picture they formed was often distorted. Early depictions, with their sprawling, tail-dragging lizards, became cultural icons precisely because they were tangible. They gave the public something they could grasp, even if science had not yet caught up to accuracy. What mattered most was the impact that society was forced to reckon with the reality of an age when life looked nothing like it did now. The intellectual shockwaves extended beyond natural history. In parlors and lecture halls, the fossils were discussed with both fascination and dread. If God's creation was fixed and perfect, how could these creatures have vanished? And if they had been wiped away, what force of nature or judgment had struck them down? The very notion of extinction was still young, a disturbing concept that forced Victorians to confront mortality not only of individuals, but of entire species. If the Earth could erase entire dynasties of life, then permanence itself was an illusion. This thought lingered like a shadow across conversations, threading scientific curiosity with existential fear. Amid this climate of uncertainty, the idea of deep time began to crystallize. Fossils embedded in layers of sediment told a clear story that the Earth's surface was not shaped in a single moment, but across eons. Each stratum was a chapter laid down in seas, rivers, and forests long vanished. To trace these layers was to walk backwards through history, each fossil a word in the language of stone. The Jurassic, with its marine shells and reptilian bones, emerged as a distinct age, one that spoke of tropical seas and reptile kingdoms. For the first time, people were forced to imagine not a young earth made in a biblical instant, but an ancient one, written across immeasurable ages. The scales of time dwarfed human history, reducing empires and civilizations to mere fragments compared with the lives of ammonites, cycads, and dinosaurs. Yet, within this vastness, there was a strange beauty. Artists painted scenes of a Jurassic Earth, their canvases filled with steaming forests, strange reptiles silhouetted against volcanic skies, and shallow seas teeming with coiled ammonites. These images, though speculative, carried a dreamlike power. They invited the public to step outside the narrow confines of human time and imagine a planet alive in entirely different ways. The fossils no longer seemed like dead relics. They became portals into deep worlds, realms that had thrived and perished without ever knowing the presence of humankind. In this way, the first scientific reactions to the Jurassic were less about cold data and more about transformation. The bones in stone forced people to abandon the comfort of certainty and step into the immensity of time. The Earth was no longer a stable stage set for humanity, but a restless planet that had hosted countless dramas before our own. Every fossil was both evidence and omen, a reminder that worlds come and go, and that even the reign of humankind is but a fragile chapter in a far greater story. Beneath the quiet hills of Bavaria lies a quarry of pale stone that changed the way humanity viewed its distant past. The Solnhofen limestone, carved open by centuries of human labor, became a window into the Jurassic unlike any other. Each slab, when split, revealed the ghostly outlines of life arrested in exquisite detail. Dragonflies with wings preserved in delicate tracery, horseshoe crabs captured mid-step, fish with scales intact, even jellyfish, creatures so fragile they seldom leave any trace in stone. Here, the Jurassic did not appear as scattered fragments of bone, but as a living tableau, a moment of an ancient world pressed flat and sealed away by time. It was as if the earth itself had chosen to hold its breath and preserve a memory in stone. From this limestone emerged one of the most important fossils in the history of science, Archaeopteryx. Its discovery in 1861 sent ripples through paleontology, for, in its delicate frame lay a paradox. It bore the unmistakable hallmarks of a dinosaur, teeth in its beak, claws on its wings, a long reptilian tail, yet its body was cloaked in feathers. Its form built for flight. The fossil seemed to whisper of transition, a creature balanced between worlds. Proof that birds were not separate creations, but the living descendants of dinosaurs. To hold such a fossil was to touch the very moment. Evolution revealed itself, not in theory but in stone. It became an icon, a fossil not just of an animal but of an idea that life was not fixed, but ever-transforming. At the same time, advances in stratigraphy brought a new precision to the study of Earth's layers. Geologists began to trace the sequence of strata with greater accuracy, realizing that each layer of rock was not random, but a page in a coherent story. Fossils served as guideposts, markers of time that could synchronize distant landscapes across Europe and beyond. Ammonites with their spiraled shells became particularly valuable, their rapid evolution turning them into clocks of stone. By charting their presence and extinction, scientists could date layers with remarkable precision, stitching together a timeline of the Jurassic that extended far beyond the reach of human memory. Yet the story of this age was not written in bones alone. The oceans of the Jurassic revealed themselves through marine fossils, ichthyosaurs with streamlined bodies that mirrored dolphins, plesiosaurs with serpentine necks that glided through shallow seas, and countless ammonites whose coiled shells crowded the seabed like living galaxies. These remains spoke of warm, shallow waters that stretched across continents, seas rich in plankton, corals, and strange reptiles that dominated the depths. To unearth these creatures was to glimpse a time when much of the world was drowned, when vast interiors of continents were submerged beneath inland seas. The earth itself seemed more fluid, its landscapes shifting with the pulse of ancient tides. On land, the traces of coal and limestone told another story. Coal beds formed from immense forests of ferns, cycads, and towering conifers, lush green worlds that once covered vast swaths of Pangaea's broken edges. Limestone, born from the accumulation of marine life, recorded the teeming oceans that lapped at those forests' margins. Together, they painted a picture of a humid, fertile earth, where warmth and moisture fueled growth on a scale almost unimaginable today. To imagine walking among those forests is to imagine a world of perpetual summer, where the air was heavy with the scent of resin and the shadows of giant reptiles fell across cycads and tree ferns. The 19th century also saw the first attempts to reconstruct entire dinosaurs from scattered bones. In dimly lit laboratories and lecture halls, skeletal fragments were pieced together into towering forms. The public, when confronted with these reconstructed giants, was overwhelmed. No cathedral had ever held figures so strange or so vast. Yet debate raged among scientists. Were these beasts cold-blooded brutes, sluggish and lumbering, or active and dynamic in ways not yet understood? The very act of reconstruction forced paleontology into both art and science, a fusion of evidence and imagination. Each skeleton was a hypothesis in 3 dimensions, a vision of what the past might have been, what began in quarries and coal seams, in limestone slabs and shattered bones, slowly expanded into something more profound, a vision of the Jurassic as a complete world, not just a stage for monstrous reptiles, but an ecosystem, forests and oceans, predators and prey, climates and continents, all bound together in deep time. Each fossil was a fragment, yet when gathered they formed a mosaic of astonishing clarity. The Jurassic was no longer a myth or a curiosity. It was a chapter of Earth's living history, written in stone with a patience beyond human measure. And so, with every slab opened, with every skeleton raised in museum halls, humanity's picture of the ancient world sharpened. The Jurassic was revealed not as a static tableau, but as a world in motion, a place of oceans rising, continents drifting, forests reaching skyward, and life itself evolving in endless forms. It was a reminder that the earth we walk today rests upon the ruins of countless worlds before it, each one alive, each one vanishing, each one leaving only whispers in stone. The unearthing of Archaeopteryx was not simply a scientific revelation. It was a cultural tremor. The fossil arrived in a century already unsettled by Darwin's On the Origin of Species, published only 2 years earlier. To Victorian society, steeped in certainty that the natural order was fixed and divinely ordained, the feathered reptile from Bavaria seemed almost sacrilegious. Here was evidence pressed into stone, undeniable and silent, yet more eloquent than any argument. It suggested that birds, those delicate creatures of the sky long viewed as symbols of purity and freedom, were not born apart from reptiles, but rather descended from them, heirs of scaled predators that once stalked the earth. The fossil carried with it a disquieting truth. beauty and ferocity, flight and predation were bound together by each hand. As the 19th century advanced, the precision of geology deepened. Stratigraphers began charting entire sequences of rock, turning landscapes into timelines. Rivers that cut into valleys exposed cross-sections of history, each layer stacked upon the next in silent order. The Jurassic strata became recognizable, not only by their fossils, but by their mineral signatures, their colors, their textures. To walk across the English countryside was to traverse millions of years beneath one's feet. Each ridge and hill a page in the Earth's unwritten chronicle. The notion of deep time was no longer abstract. It became a physical reality, embedded in every cliff face and quarry wall. Humanity began to understand that its own history was a fleeting breath compared to the vast eons written in stone. Meanwhile, the oceans of the Jurassic continued to give up their secrets. Fossil beds revealed creatures so alien that they seemed products of myth. Ichthyosaurs, with eyes as large as dinner plates, hunted the depths with a speed and elegance rivaling modern dolphins. Plesiosaurs with serpentine necks stretched their heads through shoals of fish, striking with deadly precision. Crocodile-like metriorhynchids, adapted entirely to marine life, their limbs transformed into flippers, their bodies streamlined for open water. Ammonites, endlessly spiraled, revealed both the artistry of evolution and the mathematics of survival. Their shells, following the logarithmic curves, later studied in modern science. These oceans were not empty backdrops to the dinosaurs' reign. They were vibrant kingdoms of their own, as complex and dangerous as any forest on land. The land, too, spoke in layers of coal and limestone, monuments to vanished ecosystems. Coal seams bore testimony to immense, swampy forests where cycads and conifers towered above the ground, their trunks armored with thick bark to resist storms and predators alike. Ferns spread in dense carpets beneath their shade, while horsetails rose like green pillars from the marshes. These forests were not merely vegetation, but engines of the planet, inhaling carbon and exhaling oxygen in quantities that sustained a world of giants. Each seam of coal represented millions of years of captured sunlight, compressed into black stone, waiting for human hands to burn it into fire. Limestone deposits told a parallel story, shallow seas teeming with shelled organisms, their remains accumulating over millennia until they hardened into rock. Each quarry face was a frozen reef, the whisper of ancient waters turned to stone, and then came the first attempts to give the dinosaurs a body. For decades, they had existed only as fragments, isolated bones arranged in cabinets or illustrated in scientific papers. But in the mid-19th century, museums and private collectors sought more. They wanted to see these lost titans restored, standing in full form. Skeletal reconstructions emerged, sometimes more faithful to imagination than to evidence. The Crystal Palace Park in London unveiled life-sized models of Iguanodon and Megalosaurus, hulking forms that resembled giant iguanas with lumbering stances and horn-like spikes misplaced upon their snouts. These reconstructions were deeply flawed, yet to the public they were revelations. Visitors walked among them as if through a resurrected Eden, their imaginations set ablaze by the possibility that Earth had once been ruled by such beings. The inaccuracies mattered little. What mattered was the vision. Dinosaurs had leaped from scientific obscurity into cultural legend. Debate, however, simmered among scientists. Were these beasts sluggish and cold, their blood chilled like modern reptiles, condemned to slow movements and endless basking? Or were they active and dynamic, their bones suggesting muscles and movements that belied their heavy frames. These arguments echoed in lecture halls and museums, unresolved yet vital, for they revealed a deeper truth. The fossils did not speak in a single voice. They required interpretation, and interpretation demanded imagination. In every reconstructed skeleton, in every painted scene of ancient life, there existed both science and story, a balance between evidence and vision. As the century unfolded, the puzzle of the Jurassic became ever more intricate. Fossils, once regarded as curiosities, grew into symbols of deep time. Evidence that the Earth was not static but dynamic, its face and its life continually remade. The Solnhofen slabs, the coal seams, the ammonite spirals, the towering reconstructions in museum halls. Together they told a story larger than any single discovery. They revealed a truth both humbling and exhilarating, that Earth is a palimpsest, a manuscript written and rewritten across millions of years, its pages buried in stone, waiting for human hands to read. And still, in the shadows of quarries and museum halls, the mystery deepened. For every skeleton mounted, countless questions remained unanswered. What colors shimmered on the feathers of Archaeopteryx? How did plesiosaurs glide through inland seas that no longer exist? What sounds echoed in the forests that became coal beneath our feet? Fossils gave us form, but not life, shape, but not spirit. The challenge was clear. If the past was to be resurrected, it would require more than bones. It would demand imagination, science, and a willingness to step into the depths of time itself. The Earth of the Jurassic was not a fixed stage, but a restless actor in its own drama. Beneath the countenance, forces invisible to the creatures that roamed above were already reshaping the world. Long before humanity conceived the notion of drifting lands, the planet's crust was quietly moving, its plates grinding, colliding, and tearing apart. The supercontinent Pangaea, once a singular landmass spanning from pole to pole, began to fracture during this age. Cracks deepened into rifts, rifts widened into seas, and oceans began to breathe into existence. It was a slow unraveling, one that no living creature could perceive within its lifetime, yet across millions of years the face of the Earth transformed. The world of the Jurassic was a planet in transition, continents drifting like colossal rafts upon a restless mantle, coastlines flooding under shallow seas, and landscapes dissolving into archipelagos that hinted at the geography of the future. The seeds of this understanding did not blossom until much later, when Alfred Wegener, in the early 20th century, dared to propose a radical idea that the continents themselves had once been joined, and that they drifted apart across geological time. His vision was ridiculed in his day, dismissed as fantasy. Yet the rocks of the Jurassic carried his vindication, matching coastlines, fossil lineages, divided by oceans, and the patterns of ancient mountain chains all bore silent witness to the truth. Today, the theory of plate tectonics, refined with evidence from seafloor spreading and mantle convection, confirms what Wegener once intuited. The Jurassic world was not merely ancient, it was in motion, its countenance tearing themselves, free from Pangaea to set the stage for the continents we recognize today. As the continents shifted, so too did the climate. With no polar ice caps to anchor the extremes of temperature, Earth's climate was profoundly different from our own. Models of ancient atmosphere, drawn from chemical signatures locked in rocks and shells, reveal a greenhouse planet. Carbon dioxide levels were far higher than in the modern age, driving warmth across every latitude. Even the poles, though cloaked in winter darkness, were free of permanent ice, sustaining forests where snow now falls. Sea levels rose and spread across the continents, flooding lowlands into shallow seas alive with ammonites, belemnites, and marine reptiles. Across the land, humidity and heat nurtured vast forests, tangled expanses of conifers, cycads, ginkgos, and ferns that blanketed the continents in deep green. This was no barren world of giant beasts. It was a greenhouse garden, thriving and lush, where life evolved in spectacular abundance. The evidence of this climate lies not only in fossilized leaves and pollen, but in the isotopes preserved within shells and bones. Tiny variations in oxygen isotopes record the temperature of the seas in which creatures lived and died. These chemical fingerprints allow scientists to reconstruct climates that no human eye ever witnessed. They tell of oceans that remained warm from equator to pole, of a world where seasonal variation was muted compared to our own, and of an atmosphere heavy with greenhouse gases that bound the planet in warmth. Such discoveries are not merely data points. They are windows into the mechanics of a living world, reminders that Earth's climate has always been dynamic, and that the stability of our age is fragile and rare. Amid these revelations, the perception of dinosaurs themselves began to shift. For much of the 19th century, they were imagined as sluggish monsters, lumbering in swamps, their bodies too heavy to move with grace. Yet the fossils of the Jurassic whispered a different story. Bones revealed strong muscle attachments, long strides, and agile builds. Tracks pressed into ancient mud preserved the rhythm of their movement, not the slow drag of ponderous beasts, but the dynamic pace of active animals. Even their predators, once thought to wallow at the edges of water, proved to be swift hunters, capable of bursts of speed. These were not failures of evolution. They were its triumphs, adapted to a world of abundance and warmth. The most striking revelations came not from skeletons alone, but from their microscopic details. Bone histology revealed rapid growth, a metabolism more akin to birds than to reptiles. Oxygen isotopes suggested some dinosaurs regulated their body temperatures, a clue pointing toward partial or even full warm-bloodedness. The discovery of feathered relatives, and eventually feathered dinosaurs themselves, revealed that the story of these creatures was not one of sluggish giants, but of dynamic, complex beings, a bridge between the reptilian past and the avian present. The Jurassic, then, was not merely an age of great beasts wandering primeval forests. It was a chapter in Earth's restless journey, when continents began to drift toward their modern forms, when the atmosphere swelled with greenhouse warmth, and when life itself evolved in forms both strange and familiar. Every fossil, every isotopic trace, every seam of coal and block of limestone is a fragment of this tale, a reminder that Earth is not static, but alive in time, its past woven into its present, its future already stirring in the patterns of its shifting crust and warming air. The Jurassic world stretched far beyond the imagination of its first investigators, a realm where land and sea interwove in ways both alien and strangely familiar. Shallow epicontinental seas expanded across continents, turning once dry lowlands into vast lagoons alive with color and motion. Coral reefs, ancestors of those we know today, flourished in the warmth, creating underwater cathedrals of stone and life. Ammonites spiraled through the water, their shells gleaming like celestial patterns trapped in limestone, while ichthyosaurs and plesiosaurs sliced through the waves with the speed and grace of dolphins. These oceans were not barren depths, but living theaters, each species playing its part in a drama written in salt and sunlight. On land, the forests rose in towering ranks, not yet dominated by flowering plants, but by giants of another kind. Conifers stretched skyward, their trunks rough and resinous, while cycads and ginkgos unfurled leaves in vast groves, their greenery dense and humid. Ferns carpeted the undergrowth, softening the floor beneath the colossal strides of sauropods. Coal beds and fossilized would tell us of these primeval jungles, the thick layers of carbon-rich sediment recording the lush productivity of a greenhouse world. To walk in such a forest would be to step into an atmosphere heavier, warmer, more saturated with the scent of resin and life than any modern wilderness. The air itself carried the pulse of abundance, and within these forests, life swelled in size and diversity. Sauropods, with necks like living bridges, fed upon the crowns of conifers, their massive bodies reshaping the very landscapes they walked. Herds of smaller herbivores grazed upon cycads and ferns, while predators tracked them with relentless patience. Tracks preserved in mudflats show herds moving together, suggesting social bonds and coordinated behavior. Far from being solitary, many of these giants may have thrived within complex communities, their survival intertwined not only with the plants they consumed, but with one another. It was in this age that dinosaurs revealed themselves as more than evolutionary curiosities. They were not accidents of time, but masters of their world, filling ecological roles with precision and grace. The discovery of bone growth rings, patterns much like those found in trees, revealed the pace of their lives, with many species growing rapidly to maturity, reaching sizes that dwarfed anything alive today. This rapid growth, coupled with the evidence of active metabolisms, painted a portrait of animals whose lives burned with intensity, adapted perfectly to the warmth and richness of their age. Beyond the giants, smaller forms carried secrets that would forever change the story of life. Archaeopteryx, emerging from the Solnhofen limestones, stood as a fossilized paradox, a creature with the teeth and claws of a reptile, yet adorned with the feathers of a bird. It blurred boundaries once thought absolute, reminding humanity that evolution does not draw sharp lines, but paints in gradients. Its presence in the Jurassic sky hinted at the dawn of flight, a whisper of futures to come, when the descendants of dinosaurs would inherit the air itself. Every discovery from this world, whether in limestone slabs or isotopic ratios, brought humanity closer to an unsettling realization. The Earth was not a young creation, nor a static one. It was ancient beyond comprehension, its climate capable of transformations vast and enduring, its life adapting and flourishing in ways far removed from modern experience. The warm seas, the conifer forests, the drifting continents, all bore witness to a world that existed not for humanity, but for itself. Modern climate reconstructions, built from the silent testimony of fossils and rocks, force us to confront this alien planet of the past. They show us an Earth where warmth and abundance reigned, where life adapted not in spite of change, but because of it. And in these reconstructions lies a sobering truth. The climate of Earth is not fixed. It has shifted dramatically through deep time, with or without the presence of humankind. The Jurassic greenhouse was a natural consequence of geological processes, of carbon dioxide released by volcanoes, of continents drifting into new positions, of oceans capturing and releasing heat. Yet the lessons of this past linger with a quiet urgency. For though the Jurassic climate sustained life in forms vast and abundant, it was not a climate built for the fragile world we know today. The forests, seas, and skies of the Jurassic were profoundly different from our own, reminding us that stability is temporary, and that the present balance of Earth's systems is neither eternal nor guaranteed. The breakthroughs of the last century, isotope analysis, plate tectonics, fossil histology, transformed the Jurassic from a realm of speculation into a world of vivid reality. But in doing so, they also reminded humanity of its own smallness. The creatures that once ruled the earth were not destined for eternity, nor were the continents fixed in place. Life, land, and climate alike are bound to cycles of change, so vast that even empires, civilizations, and histories seem like sparks in a storm. The Jurassic Age is more than a chapter in prehistory. It is a mirror reflecting both the resilience of life and the fragility of permanence. The story of the Jurassic does not end with discovery. It only grows stranger, more profound, and more difficult to explain. For within this age of warmth and abundance lies a puzzle that continues to haunt science. Why did the dinosaurs, of all creatures, rise to such power, while so many of their reptilian kin faded into obscurity? The Triassic had seen a crowded stage, crocodile-like archosaurs, armored etosaurs, and countless other contenders, all vying for supremacy in the newly opened niches of a recovering world. Yet, as the Jurassic unfolded, these rivals dwindled, leaving dinosaurs to expand into realms once shared. It was not a single stroke of fortune, nor a catastrophe that cleared the way, but something subtler, written deep into biology and environment alike. Dinosaurs grew faster, adapted more readily, and carried within them a strange advantage. Their bones, laced with air sacs, made their bodies both massive and light, granting them stamina and resilience in a climate that favored endurance. Where others faltered, dinosaurs thrived, and in doing so, reshaped the course of life itself. Their triumph gave birth to giants the world had never seen before, sauropods, the largest land animals in history. With necks stretching like living bridges between earth and sky, they could strip the crowns of conifers in a single sweep. Their immense size was not excess, but survival. In a world of predators, bulk was protection. In a land of endless forests, height was access to untapped resources. Entire herds of these titans left behind great pathways carved through the forests, ecosystems bending beneath the weight of their presence. Their skeletons, when uncovered millions of years later, dwarfed human imagination, leaving scientists to ask how such creatures had lived, how they had breathed, how they had thrived in numbers. Alongside these giants, a quieter revolution stirred. Some dinosaurs began to wear feathers, not for flight at first, but for warmth, for display, perhaps even for communication. These delicate filaments hinted at futures not yet written, a slow march toward wings and the conquest of the skies. In the flutter of protofeathers, one can almost sense the distant echo of birdsong, the promise of another age still slumbering in evolution's vault. Archaeopteryx, caught forever in stone, preserves this transition with haunting clarity, claws, teeth, and tail fused with feathers. A bridge across the divide between reptile and bird. Beyond the land, the seas belonged to rulers of their own. Plesiosaurs glided with paddle-like limbs, their long necks darting after schools of fish, while ichthyosaurs, shaped like dolphins yet birthed from reptiles, raced through the depths with unmatched speed. Ammonites spiraled through the waters, their shells intricate as galaxies, their numbers so vast they became both predator and prey, keeping the marine web in motion. These oceans were not tranquil voids, but vibrant, alien worlds, their drama unfolding beneath waves that never knew ice. What made such abundance possible? Fossil soils, leaf impressions, and chemical signatures all point to a planet swathed in warmth and moisture. A greenhouse world sustained by high levels of carbon dioxide and vast volcanic outpourings. Rainfall nurtured sprawling forests, seas flooded the continents, and climates shifted gently, without the abrupt collapses that scar so many other epochs. For tens of millions of years, stability reigned, a rare gift in Earth's turbulent history. And yet, here the mystery deepens. How did such a climate endure so long, when Earth is prone to chaos, two swings of heat and cold, two sudden upheavals? Was it the drifting continents, spreading heat evenly across latitudes? Was it the deep oceans, capturing and releasing warmth with slow precision? Or was it something yet unseen, a balance hidden in the very chemistry of the air and seas? Truth remains elusive. The fossil record whispers, fragments, isotope ratios, sketch outlines, but the full picture lies just beyond reach. This is the paradox of the Jurassic, a world both understood and unknowable, where dinosaurs rose to their glory, where forests and reefs flourished, where seas swarmed with life, and yet the mechanisms of stability remain a riddle. Perhaps the answer lies not in a single cause, but in the harmony of many, the dance of continents, the breath of volcanoes, the slow rhythm of oceans, and the resilience of life itself. To peer into this mystery is to confront the fragility of the present. For, if Earth could maintain such abundance for so long, it could also end it as it has done before. The age of dinosaurs was vast beyond human measure, but it was not eternal. Their dominance, their lush world, and their endless summers would one day yield to change. And in that reminder lies a haunting reflection that stability is the rarest condition of all, and that life's greatest empires, no matter how mighty, are only guests in time's vast theatre. The giants of the Jurassic did not live in isolation. Their world was a theatre of constant tension, a balance of life and death, predator and prey, abundance and hunger. Where sauropods roamed in herds like moving fortresses, predators evolved. To match their scale, Allosaurus, with its serrated teeth and bone-crushing bite, stalked the conifer forests and floodplains, its movements silent until the final sprint. Unlike the lumbering images once painted in textbooks, new evidence reveals it as agile, efficient, a hunter that used ambush and strategy rather than brute force alone. It was a predator shaped by the very existence of giants, its anatomy honed to challenge creatures far larger than itself. Yet even the most fearsome carnivores were not solitary kings. They lived within ecosystems of astonishing intricacy. Smaller theropods darted through undergrowth, preying on reptiles, mammals, and insects, while packs of raptors, some feathered, some not, hunted with a coordination that hinted at intelligence. In their coexistence, one finds an early echo of modern ecosystems, where roles were not fixed but constantly shifting in the great web of survival. The plants, too, told a story of evolution and adaptation. Jurassic forests were dominated by conifers, cycads, and ginkgos, a green world of towering trees and fern-filled understories. These plants thrived in the warmth, spreading across continents in belts of lush vegetation. Their resin hardened into amber, capturing in golden prisons the smallest witnesses of the age, insects with delicate wings, pollen grains, even fragments of feathers. Such tiny fossils, invisible to the eye for millions of years, hold secrets as profound as the bones of giants, revealing that the Jurassic was not only an age of colossal scale, but also of exquisite detail. Marine ecosystems mirrored this richness. The ammonites, endlessly varied in form, became more than inhabitants. They became markers of time itself. Their shells, preserved in layer upon layer of limestone, now guide paleontologists in dating the rocks that entomb them. Every spiral tells a story of evolutionary innovation, of adaptation to currents, predators, and climates. Alongside them, coral reefs flourished in shallow seas, harboring a biodiversity that foreshadows the great reefs of today. But unlike modern reefs, no polar ice capped the seas, no glacial cycles disturbed the warmth. Instead, the oceans carried heat across the globe, knitting together a climate that seemed almost eternal. Still, the question lingers, why such stability? The evidence points toward a delicate equilibrium. Volcanic activity released vast amounts of carbon dioxide, driving global warmth. Yet at the same time, weathering of mountains and the burial of organic matter in swamps and shallow seas acted as counterweights, pulling greenhouse gases from the air. Earth, in this moment, found a balance, a rare harmony that sustained forests, oceans, and skies in unbroken abundance for tens of millions of years. It is a reminder that life itself is intertwined with geology and atmosphere, each influencing the other in cycles that span eons. In this harmony, dinosaurs achieved not only survival but dominance. Their physiology, lightened bones, efficient lungs, rapid growth allowed them to flourish in ways their Triassic rivals could not. They became more than inhabitants. They became architects of ecosystems. Their grazing shaped forests. Their migrations redistributed nutrients. Their very existence altered the evolutionary path of plants and animals around them. When one imagines the Jurassic, it is not just a scene of beasts moving across the land, but a living planet reshaped by their presence. And yet, beneath this triumph lies the deeper riddle, why this age of life endured so long, untouched by the cataclysms that shattered other periods. Stability in Earth's history is an exception, not a rule. To contemplate the Jurassic is to look upon a rare moment when the planet allowed life to expand without interruption, when evolution could stretch its canvas wide. But as with all such moments, it could not last forever. Somewhere in the distance of time, the seeds of change were already waiting. Silent in the depths of the earth, patient in the shifting of plates, inevitable in the laws of the cosmos. The Jurassic was a world of giants and oceans, of forests without winter, of skies that would soon give rise to birds. But it was also a world suspended in mystery, balanced between abundance and impermanence. Its story reminds us that even in the grandest ages of life, permanence is an illusion. The clock of geology ticks on, and every empire, no matter how vast, is built on borrowed time. Beneath the calm illusion of a timeless Eden, the Jurassic world was never still. Deep within the planet's crust, forces of unimaginable scale stirred. Vast supervolcanoes and flood basalts, those titanic outpourings of molten rock, periodically reshaped the atmosphere and the seas. Each eruption released rivers of lava and skies filled with ash, altering climate and chemistry in ways subtle yet profound. Though the Jurassic is remembered as an age of stability, the rocks whisper of interruptions, short pulses when ecosystems faltered, when warmth wavered, and when life trembled at the edge of collapse. It is here, in these fragile moments, that the hidden machinery of Earth is revealed. Even the orbit of the planet played its part. The slow dance of celestial mechanics, what scientists call Milankovitch cycles, tugged at Earth's climate like a cosmic metronome, shifts in the tilt of the axis, in the eccentricity of orbit, in the gentle wobble of precession, all combined to shape seasons, rainfall, and the rhythm of life. In the Jurassic, with no polar ice to anchor extremes, these cycles may have been felt most vividly in monsoons sweeping across Pangaea's broken lands, in the flooding of shallow seas, in the ebb and flow of forests. Life, vast and abundant, moved in step with the silent choreography of the heavens. Even the very stones of that world preserve a record of deeper mysteries. Within the layers of Jurassic rock, geologists find evidence of magnetic reversals, moments when Earth's magnetic field weakened, collapsed, and returned reversed. These reversals, scattered across time, are imprinted in iron-bearing minerals, like compass needles frozen in stone. Though life continued, scientists wonder what such weakened shields might have meant. Did cosmic rays intensify, altering evolution in ways too subtle to trace? Did radiation shape genetic change, nudging creatures along paths unseen? The rocks are silent, but the questions remain. While geology and orbit sculpted the world, biology reached its own extremes. The sauropods, with necks stretching longer than buses and bodies, heavier than a fleet of elephants, stood as living paradoxes. How did such immense creatures breathe, their lungs filling across necks longer than most houses? Evidence suggests a system of air sacs similar to modern birds, recycling oxygen with breathtaking efficiency. Their bones were latticed with air cavities, making them lighter than their size would suggest. Their hearts, it is thought, pumped with extraordinary force, driving blood to the far reaches of their towering frames. Yet even these colossal beings moved with grace, their long tails counterbalancing their necks, their vast bulk spread across columnar legs like living architecture. They were more than animals. They were triumphs of biomechanics, embodiments of evolution's audacity. And yet, in the shadows of giants, life of an entirely different scale flourished. Insects, delicate, elusive, and often unseen in the fossil record, wove the invisible threads of Jurassic ecosystems. Fossilized amber offers fleeting glimpses, dragonflies with wingspans wide as ravens, beetles that scuttled beneath ferns, termites that shaped soil long before mammals had a chance. They pollinated plants, cycled nutrients, and became the foundation of countless food webs. Without them, the great forests would have been silent, and the skies bereft of birds. Yet, to come, their scarcity in the fossil record makes them all the more mysterious, an empire of the unseen, essential yet half-vanished from history's pages. Yet even in this world of abundance, the Jurassic carried with it pulses of uncertainty. Fossil records reveal moments when biodiversity dipped, when species disappeared in clusters not large enough to mark mass extinctions, but significant enough to raise questions. These extinction pulses hint at stresses beyond ordinary change, perhaps triggered by volcanism, by climate shifts, by the unseen hand of orbital cycles. They remind us that stability, even stretched across millions of years, was never absolute. Beneath the forests and seas, life always balanced on a knife's edge. Threatened by forces too vast to control, the extreme edge of science lies in these unanswered questions. How close did the Jurassic come to disaster? Were its giants spared by fortune, Or did resilience run deeper in the fabric of its ecosystems? Each fossil, each isotope, each magnetic line in stone is a fragment of a puzzle too vast for certainty. What remains is a portrait of a world at once fragile and unyielding, shaped by forces from the heart of the earth to the pull of distant planets. The Jurassic was more than an age of dinosaurs. It was a crucible of extremes: fire and stone, orbit and tide, bone and breath, all bound together in a world that balanced between paradise and peril. And in that balance, life reached heights never seen before, heights that even now leave us searching for answers in stone. The pulse of the Jurassic still echoes in stone, and as science deepens its gaze, the mysteries only grow larger. Consider the sauropods again, nature's most improbable creations. They were not simply scaled-up animals, but evolutionary experiments pushed to the very edge of possibility. Their immense size forced radical solutions. The very architecture of their skeletons reveals a compromise between strength and lightness. Vertebrae honeycombed with air chambers, ribs fused for stability, neck bones stretched like bridges. Each design choice was not random, but dictated by the physics of survival. To move such bulk across the land, they needed efficient energy use, feeding strategies to sustain endless appetites, and lungs capable of drawing more oxygen from the Jurassic air than mammals could ever dream of. These animals were mobile ecosystems, each step shaking the ground, each breath reshaping the balance of carbon in their forests. Their lives, though monumental, were also fragile. A sauropod calf, scarcely larger than a human, would have faced a perilous path to maturity. Only a fraction survived the gauntlet of predators, disease, and famine. But those who endured grew into titans that no predator dared challenge. In their shadows, other dinosaurs evolved their own strategies: armored stegosaurs with plates shimmering in the sun, swift carnivores whose cunning rivaled their speed, and feathered theropods that hinted at a future where wings would replace claws. Yet the Jurassic was never only about the land. The oceans, vast and primeval, were kingdoms of their own. Marine reptiles, ichthyosaurs, shaped like dolphins, plesiosaurs with serpentine necks, pliosaurs with skulls, rivaling tyrannosaurs in length, dominated the seas with grace and terror. Ammonites, with their spiraled shells, drifted in endless variety, their forms both delicate and resilient, surviving for millions of years as symbols of adaptability. The seas teemed with life alien to modern eyes, yet familiar in purpose. Predator and prey, hunter and hunted, a mirror of the struggles on land. But beneath this vibrant surface lay the ever-present hand of Earth's deep machinery. Volcanism did not simply scar the land. It altered the air itself. When supervolcanoes or flood basalts erupted, they released not just lava, but gases that changed the atmosphere's chemistry. Carbon dioxide levels soared, greenhouse warmth deepened, and oceans absorbed the burden of acidification. Some intervals left behind black shales, rich in organic matter, silent witnesses to seas that lost their oxygen, where life suffocated in darkness. These were not permanent crises. The world recovered, but each was a reminder of fragility. Life thrived not because Earth was safe, but because it adapted to danger. And above it all, the invisible mechanics of the cosmos continued to steer the rhythm. The tilt of the planet, the pull of the moon, the path around the sun, each adjustment shifted rains, moved winds, shaped deserts and swamps. In the Jurassic, without the stabilizing anchor of polar ice, these changes rippled more strongly through ecosystems. The forests of cycads and conifers waxed and waned with the shifting skies. Shallow seas advanced and retreated, sometimes swallowing entire landscapes, sometimes receding to reveal mudflats rich with new life. To the creatures living then, these changes unfolded slowly, over generations beyond memory. To the eye of geology, they appear as sudden turns of fate, and through it all, extinction pulses whispered warnings. The fossil record shows patterns that cannot be ignored, sudden dips in diversity, moments when ecosystems buckled. Some losses were quiet, affecting only smaller branches of life's tree. Others hinted at the beginnings of catastrophe. Perhaps toxins from eruptions poisoned food chains. Perhaps ocean chemistry shifted too swiftly for marine life to adapt. Perhaps climate tipped in ways that left forests vulnerable. Whatever their cause, these events remind us that even in Earth's most bountiful ages, life teetered on an edge, invisible to those who lived it. The deeper science looks, the more the Jurassic resists simple explanations. It was a world suspended between order and chaos, its apparent paradise laced with tension. Giants ruled, yet their very existence was fragile. Ecosystems flourished, yet collapse lingered near. The climate was stable for millions of years, yet carried hidden instabilities that could unravel it in moments. The extreme edge of science lies in piecing together these contradictions, how Earth sustained abundance for so long, how it survived crises without falling into ruin, how life not only endured but reached new heights of complexity. In every volcanic layer, in every isotopic trace, in every fossil bone, the answers remain fragments of a grander truth still beyond full comprehension. The Jurassic was an age of extremes. Fire from the depths, tides of the heavens, giants of flesh and bone, ecosystems both fragile and enduring. And perhaps that is its most haunting lesson, that paradise and peril are never far apart. That the same forces which create abundance also carry the seeds of destruction. It is a reminder that Earth itself is not a passive stage, but an active player shaping, testing, and reshaping life in endless cycles of creation and challenge. Beneath the ancient skies of the Jurassic, the Earth seemed to have found a rare balance. For tens of millions of years, warmth bathed the countenance. Rains nurtured forests, and life flourished in abundance. Scientists, searching for answers, often begin with one of the simplest, yet most profound clues. The atmosphere itself. Levels of carbon dioxide in the Jurassic were several times higher than today's. Volcanic outgassing, constant and immense, filled the skies with this invisible gas, far from being a poison to life. In that world it was fuel, a greenhouse blanket that wrapped the planet in stability, preventing harsh winters, softening extremes, and creating a near-uniform warmth. From equator to poles, without polar ice to shift oceans and winds, the climate settled into rhythms, both gentle and long-lasting. For millions of years, Earth's stability was unlike any before or since. A kind of climatic cradle where ecosystems could grow unbroken. In this cradle, the dinosaurs rose to dominance. They were not inevitable rulers, yet their bodies held secrets that gave them the advantage. Their growth was rapid, their bones recording astonishing speeds of development. Many reached maturity faster than their reptilian rivals, overwhelming ecosystems with sheer numbers. Their eggs, laid in vast clutches, multiplied their chances of survival, ensuring that in every generation, some would endure. Their metabolisms, likely warm-blooded or near to it, gave them endurance unknown to the lumbering reptiles that came before. Where other creatures tired, dinosaurs thrived, filling niches of every shape and scale, from nimble hunters darting through underbrush to sauropod giants shaking the ground beneath forests. Evolution had armed them not with one secret, but many, weaving together a tapestry of advantages that, in concert, tipped the balance of Earth's story. The forests that sheltered them were no less extraordinary, fed by volcanic carbon dioxide. Plants grew in profusion, their leaves thick, their canopies stretching endlessly. Conifers dominated uplands, while cycads and ginkgos spread across lowlands, weaving green tapestries where herds could graze and predators stalk. Even ferns, often overlooked in the modern world, reached vast abundance, carpeting wetlands and riverbanks. Each eruption that darkened skies with ash also fertilized the land with minerals, ensuring that life did not merely recover, but rebounded with vigor. These forests were not static backdrops. They were engines of planetary transformation, drawing in carbon, releasing oxygen, and maintaining the delicate balance that life required. Yet stability was not uniform, nor was the world a single expanse of sameness. Beneath the crust, the ceaseless drift of continents sculpted a world in motion. The great supercontinent, Pangaea, once unified, was tearing apart, its rift valleys brimmed with lava, birthing new oceans. Plate tectonics created coastlines, mountain ranges, and inland seas, diversifying habitats at a planetary scale. Where once deserts had sprawled unbroken, now climates shifted. Rainfall increased in many regions, forests advanced into new territory, and ecosystems fractured into countless ecological niches. This fragmentation spurred diversity, giving life room to adapt, specialize, and radiate into forms more complex and varied than ever before. Among these forms, a revolution quietly unfolded. Small, feathered theropods began to rise above their reptilian kin. Feathers, perhaps first evolved for insulation or display, became tools for gliding, and eventually for powered flight. In the limestone beds of Germany, a single fossil would later capture this turning point. Archaeopteryx, the first bird, its wings feathered yet clawed, its skeleton bridging the divide between predator and aviator. It was a creature of transition, evidence that evolution was not fixed but fluid, ever searching for new paths. The sky, once the realm of pterosaurs alone, now held new claimants. The future would belong to them. Taken together, these forces, the steady warmth of a greenhouse Earth, the evolutionary edge of dinosaurs, the fertilizing hand of volcanism, the restless creativity of shifting continents, and the first beating wings of birds, wove the Jurassic into a golden age. Compared to what came before, life seemed stronger, richer, more enduring. Compared to what came after, it was paradise. The great extinctions of the Cretaceous and the Paleogene still lay far ahead, waiting in the shadows of time. But for this long span, Earth achieved something rare, a balance where abundance reigned, and biodiversity reached heights unseen again for millions of years. The mystery of this age lies not only in its grandeur, but in its endurance. For tens of millions of years, paradise persisted. The question that lingers is why. What forces allowed life to thrive so steadily when before and after Earth swung violently between ruin and renewal? The answers, still debated, lie hidden in stone in the air bubbles trapped in amber, in the magnetic traces etched into basalt, in the bones of titans that once walked. Each fragment speaks, but never the full truth. The Jurassic whispers of balance, of abundance, of life's triumphs. But it also reminds us how precarious paradise truly is. The golden stability of the Jurassic did not mean the world was without tension. Beneath the quiet surface of forests and plains, there were delicate balances that could easily shift. High levels of carbon dioxide sustained lush vegetation, but they also held the potential for sudden climate swings if volcanic outgassing waned or intensified. The warmth that nurtured the dinosaurs was both gift and gamble. Yet somehow, for nearly 60 million years, the system endured with uncanny steadiness, as though Earth had discovered a rare equilibrium between fire and air, sea and sky. Within this stability, the dinosaurs expanded not merely in size but in form and function. The sauropods became the great architects of ecosystems, reshaping landscapes with every movement. By stripping forests of foliage, they cleared paths for sunlight to reach the forest floor, allowing smaller plants to flourish. Herds numbering in the hundreds likely migrated across continents, leaving behind vast trails of broken branches and fertilized soils. In this sense, they were not just inhabitants of the Jurassic world, they were engineers of it, transforming their environment as profoundly as the volcanic eruptions and drifting continents around them. Predators, too, evolved with the times. Theropods grew sleek and efficient, balancing speed with intelligence. Their teeth were serrated like saw blades, their senses honed to detect movement in the dim light of dawn or dusk. In the shadow of giants, they thrived by hunting smaller prey or scavenging the remains of the titans. The arms race between predator and prey became a driving force of adaptation, fueling sharper claws, keener eyesight, and more complex behaviors. The Jurassic was not merely a world of survival, it was a theater of innovation, where life constantly tested new strategies in an endless struggle for advantage. The oceans mirrored this intensity. Marine reptiles ruled the seas with equal majesty, plesiosaurs with their long necks sweeping through shoals of fish, ichthyosaurs slicing through waves like living torpedoes, crocodile-like metriorhynchids pursuing prey with terrifying efficiency. Beneath them, ammonites spiraled through the currents, their shells delicate yet resilient, endlessly diversifying into new forms. Coral reefs thrived in the warm, shallow waters, hosting ecosystems as rich as modern tropical seas. To glimpse these oceans would have been to witness an alien planet, a place where predators of all shapes and designs competed in an endless ballet of survival. But perhaps the most mysterious layer of the Jurassic world lies in what remains unseen. The world of insects. Their fossils are rare, preserved mostly in amber that would not become common until the Cretaceous. Yet their presence is undeniable. They pollinated plants, spread spores, recycled nutrients, and served as the quiet foundation of food webs. Without them, forests could not have thrived, and the great herbivores would have found less to eat. The buzzing world of dragonflies, beetles, and primitive wasps was a hidden empire, shaping life in ways as profound as the thunderous footsteps of dinosaurs. Their absence in the fossil record is a silence that scientists strain to fill, knowing that their influence must have been immense. All these threads, atmospheric warmth, volcanic fertility, continental drift, evolutionary ingenuity, and hidden insect worlds, converge to create the Jurassic's golden age. And yet, woven through its stability, there were whispers of fragility. Geological records suggest pulses of extinction even within this era of abundance. Species vanished without clear cause, replaced by others in a steady turnover that hints are disruptions too subtle for stone to fully preserve. Some point to fluctuations in carbon dioxide, others to ocean anoxia or minor asteroid impacts. Whatever the triggers, these events remind us that even in times of apparent stability, life always balances at the edge of change. The Jurassic, then, was not merely an age of triumph, it was an age of resilience, where ecosystems absorbed shocks and rebounded, maintaining their abundance despite hidden pressures. Perhaps this resilience itself is the greatest lesson of the age. Life is never static, even in paradise. It adapts, transforms, and endures until the day comes when even the strongest balance falters. Beneath the grand narrative of the Jurassic lies another layer, one less certain, woven from the fabric of speculation. It is here, at the margins of knowledge, that imagination leans against evidence, where bold theories attempt to bridge the gaps left by stone and fossil. The mainstream explanations offer stability, rooted in measurable climate data, evolutionary trends, and the record of tectonic drift. But there are also questions the evidence does not fully answer. How did creatures so vast as the sauropods sustain their titanic lives? What hidden forces shaped the atmosphere, the magnetic field, the very foundations of biology? In the silence of deep time, science sometimes allows itself to wonder. Among these wonders stands the physiology of the giants themselves. Sauropods, the long-necked behemoths that stretched more than 30 meters from head to tail, should not have been possible according to the ordinary constraints of biology. Their necks were too long to pump air with simple lungs, their bodies too massive to cool efficiently, and yet they thrived. Fossilized bones reveal cavities that suggest the presence of air sacs, a system much like those in modern birds, where air flows in a one-way circuit rather than the back and forth of mammalian lungs. Such a mechanism would have given them remarkable efficiency, reducing their weight, cooling their bodies, and allowing steady breathing even as they grazed high in the canopies. In this sense, sauropods may not have been merely reptiles on a colossal scale, but creatures whose physiology whispered of a different lineage, one that pointed toward the avian future. Some scientists have gone further, suggesting that the atmosphere itself enabled their gigantism. Evidence from fossilized amber hints that oxygen levels may have been higher than today, not only supporting colossal dinosaurs, but also dragonflies. With wingspans rivaling modern hawks, and insects of proportions unseen in later epochs. A hyperoxygenated atmosphere would have energized metabolism, fueled rapid growth, and perhaps even altered the thresholds of survival. Yet the data remains debated, with some studies finding only modest differences. Was the Jurassic air richer, thicker, easier to breathe? Or did life itself push against the limits of physics, forcing adaptations where none should have been possible? Beneath the surface of the Earth, another mystery flickers in the rock record, the magnetic field. Today, it shields life from cosmic radiation, guiding migratory creatures and stabilizing the delicate balance of atmosphere. But in the Jurassic, magnetic reversals were frequent. North and south poles flipped, sometimes within tens of thousands of years. The field itself may have been weaker, more unstable, less reliable. Could this instability have influenced evolution, exposing organisms to bursts of radiation that sparked mutations? Some suggest that the churn of magnetic flux may have played a role in accelerating diversity or in shaping behaviors of animals sensitive to geomagnetism. It is a speculation difficult to prove, yet haunting in its possibility, that invisible forces from the core of the earth subtly wrote the script of life on its surface. Speculative thought does not end with physics or atmosphere. Some paleobiologists have imagined great ecological waves driven by microbial or fungal blooms. In a world so warm and humid, fungi could have flourished with staggering abundance, decomposing fallen forests, recycling nutrients on a planetary scale. Microbial shifts in the oceans may have triggered pulses of oxygen depletion, invisible in fossils yet devastating to ecosystems. These unseen kingdoms, so often overlooked, might have been quiet architects of boom and collapse. If so, then the Jurassic was not ruled only by dinosaurs, but by organisms far too small to fossilize empires of spores and cells, shaping the fate of giants without leaving a trace of their dominion. Beyond science lies the question that bends toward philosophy. What if the asteroid had never struck? Would the Jurassic pattern of life have continued into eternity, or was it already unstable, waiting for some other catastrophe to sweep it away? Could dinosaurs have evolved further intelligence, culture, perhaps even civilization? Fossilized skulls reveal that some theropods, like troodontids, had relative brain sizes approaching those of modern birds. They were agile, problem-solving predators. Given another 60 million years, might such creatures have walked the path toward sentience? Or was the very architecture of their bodies, tails, balance, and reproductive strategies forever unsuited for such a destiny? The fringes of speculation even dare to suggest that dinosaurs may have been more intelligent than we imagine, not in human-like cognition, but in forms alien to us. Cooperative hunting, complex communication, migratory coordination, these hint at social structures richer than raw instinct. To dismiss them as mere brutes of flesh and bone may be to underestimate evolution's creativity. Intelligence takes many shapes, and in the long reign of the dinosaurs, there was time enough for experiments now lost to extinction. Thus the speculative edge of Jurassic science is both thrilling and humbling. It reminds us that the fossil record is not a book with every page intact, but a fragmented manuscript with long passages missing. Between the lines, theories multiply, some grounded, others fragile, all searching for meaning in the silence of stone. Whether air sacs or oxygen-rich, skies, magnetic shifts, or microbial surges, the truth remains elusive. Yet in that elusiveness lies wonder. For the Jurassic is not just a story of what we know, but of how much we have yet to imagine. And yet, even as speculation stretches its reach, it is tethered to evidence, to the fragments of bone, the isotopes frozen in minerals, the magnetic echoes etched into ancient lava flows. Each fragment is a clue, but the gaps between them are vast. It is in those gaps that imagination takes root. When paleontologists study the hollow chambers inside sauropod bones, they see not only the past, but also the possibility of a respiratory system unlike any other land animal before or since. The sheer size of these creatures demands such invention. A simple lung would collapse under the strain, unable to pull enough oxygen through necks longer than a city bus. Air sacs interlaced through the skeleton may have lightened their load, filled them with buoyancy, and allowed their massive frames to walk where physics said they should crumble. But the environment itself may have joined in this conspiracy of gigantism. The Jurassic atmosphere was a dynamic thing, rich with carbon dioxide and possibly richer in oxygen than today. Some reconstructions suggest levels approaching 25 to 30%. Compared to the modern 21, such an atmosphere would not only fuel enormous animals, but also foster the dominance of forests so dense they seemed eternal. Conifers and cycads flourished, their leaves drinking deeply of the carbon exhaled by volcanoes. Ferns carpeted the undergrowth, feeding herds that thundered across floodplains. Even insects, their tracheal systems bound by the limits of oxygen diffusion, could stretch their anatomy into monstrous proportions. Fossilized dragonflies with half-meter wingspans are a whisper of that world, a reminder that atmosphere itself sets the size of life. Yet, if the air of the Jurassic was thick and nourishing, the magnetic shield above it was uncertain. The Earth's field flipped often during this age, leaving bands of magnetized rock-like barcodes across the ocean floor. Each reversal was sudden on geological timescales, perhaps within a human lifetime, and between reversals the field weakened. With a fainter shield, more cosmic radiation would have reached the surface, perhaps nudging DNA toward mutation. Some suggest this invisible influence may have accelerated evolutionary experiments. From feathered theropods to armored stegosaurs, a silent hand reshaping lineages. Life did not merely endure these reversals. It may have thrived on their instability. If radiation and air sacs sculpted the giants, then fungi and microbes may have orchestrated the unseen cycles of plenty and collapse. The Jurassic world was humid, fertile, and alive with decay. Forests of conifers rose and fell, their fallen trunks devoured not only by insects but also by fungi that surged in waves. These decomposers recycled the Earth's nutrients, releasing carbon and oxygen back into circulation. At times, they may have bloomed beyond control, reshaping ecosystems as profoundly as any predator. In the oceans, microbial blooms may have triggered brief pulses of anoxia, dead zones where fish perished and marine reptiles struggled. Such events do not leave skeletons, they leave only absence. And yet absence itself is a signature, a ghostly reminder that the smallest of organisms may rule over the greatest. Speculation deepens into philosophy when one contemplates the absence of extinction. The asteroid that would one day erase the dinosaurs was still millions of years away. Had it not come, would the Jurassic world have continued indefinitely? Evolution is a river, not a circle. It does not repeat itself. Dinosaurs might have continued, diversifying, adapting, perhaps even discovering forms unimagined today. The small, keen-eyed theropods already carried the blueprint of birds within them. Their brains were enlarging, their senses sharpening. Could intelligence have arisen along a different branch, not from primates, but from creatures with scales and feathers, talons and beaks? A parallel world, where language was spoken in hisses and clicks, where tools were wielded by clawed hands. It is speculation, yes, but speculation that bends the imagination toward the fragility of our own story. The question of dinosaur. Intelligence lingers at the edges of science. Troodontids, with their relatively large brain-to-body ratios, may have been as clever as modern birds. They may have hunted with coordination, nested with care, and remembered landscapes with detail. Their intelligence was not human, nor need. It had been, intelligence is not a ladder leading only to humanity. It is a branching tree with many paths. Some lead to crows that solve puzzles, elephants that mourn, octopuses that play. Others may have led, in the Jurassic, two forms of awareness lost to time. Perhaps dinosaurs communicated with vocalizations more complex than roars, or through colors and movements in ways invisible to fossils. Such possibilities remind us that we measure the past with the tools of the present, and in doing so, we may overlook what cannot be captured in stone. Thus, the speculative edge of the Jurassic is not simply a catalogue of theories, but a meditation. On limits, it asks where science ends and imagination begins. Air sacs and oxygen-rich skies hint at physiology beyond expectation. Magnetic shifts whisper of invisible forces shaping destiny. Fungal kingdoms remind us of powers that leave no bones but command entire ecosystems. And philosophical speculation leads us to the haunting question of alternate histories, of intelligence that might have been. In these reflections, the Jurassic is revealed not only as an age of giants, but as an age of mysteries, an age that challenges the very boundaries of knowledge. Yet discovery today is not confined to pickaxes and brushes. Technology has become a second set of eyes, capable of seeing into stone without breaking it. CT scanners, machines once designed for medicine, now peer into fossils with beams of light, finer than the edge of a hair. Skulls are reconstructed in 3 dimensions, revealing the hidden contours of brain cavities, the looping canals of inner ears, the delicate architecture of sinuses and air sacs. From such ghostly shapes, paleontologists can infer whether a dinosaur heard low rumbles or high whistles, whether its balance was tuned for running or for flight. Muscles and organs, long vanished, can be digitally reconstructed, breathing life into bones that have lain silent for millions of years. In this way, fossils are no longer just relics. They are data, maps of vanished anatomies that can be explored again and again without destroying their fragile shells. Beyond bones, a parallel science rises from the soil, paleobotany, the study of ancient plants. In sediments once shaded by conifer forests, scientists extract pollen grains no larger than dust, each grain a time capsule of climate and ecology. Leaf impressions reveal the shapes of ferns and cycads, while petrified wood preserves the cellular details of trees that once towered over Jurassic landscapes. By piecing together these fragments, researchers reconstruct entire ecosystems, forests, rebuilt leaf by leaf, canopy by canopy. They simulate how light filtered through branches, how roots anchored soil, how vegetation responded to volcanic gases that enriched the atmosphere with carbon dioxide. The Jurassic world is thus revealed not only through the animals that walked its plains, but through the forests that sustained them, vast green engines that regulated climate and fed the cycles of life. Supercomputers now carry this reconstruction further, modeling the climate of deep time. By feeding ancient atmospheric data, volcanic activity, and continental positions into equations of physics and fluid dynamics, scientists simulate the greenhouse world of the Jurassic. They trace how monsoons may have swept across the interior of Pangaea, how warm currents circulated through shallow seas, how deserts expanded and contracted with shifting winds. These models suggest a world without polar ice caps, where temperatures were steady and humid even at high latitudes. It was a world in which lush vegetation spread far beyond the tropics, sustaining the herds of sauropods that marched in slow migration across entire continents. In this way, computers act as time machines, not through fantasy but through mathematics, conjuring climates that no human eye has seen. And yet, in this pursuit of resurrection, a boundary remains fixed. DNA, the thread of life itself, does not endure the ages. Experiments reveal that even under the best conditions, DNA breaks apart over hundreds of thousands of years, its code unraveling until nothing remains. The Jurassic lies more than 150 million years behind us, far beyond the reach of molecular survival. No amber-encased mosquito, no fragment of bone could preserve its essence. For this reason, the visions of resurrected dinosaurs belong to the realm of fiction, immortalized by stories such as Jurassic Park. Science, in its rigor, reminds us that memory is not resurrection. The past can be reconstructed, imagined, even simulated, but it cannot be restored in flesh. Still, the search expands. Satellite imagery scans the surface of Earth, mapping regions that may conceal fossil-rich layers. Subtle color shifts, invisible to the human eye, betray the presence of sediments once laid in rivers or seas. Archaeologists and paleontologists follow these digital signals to the ground, uncovering sites where ancient bones lie waiting. The Earth itself, surveyed from orbit, becomes an atlas of lost worlds, guiding hands and minds toward the fragments of prehistory. Modern science, in its union of fieldwork and technology, extends a bridge across time. Shards of bone, grains of pollen, echoes of climate, simulations of atmosphere, each is a thread woven into the tapestry of the Jurassic. The story that emerges is not one of nostalgia, but of revelation. For in uncovering the deep past, humanity does not simply learn what once was. It learns what worlds are possible, how life endures and transforms, and how fragile the balance of existence has always been. The Jurassic remains silent, its voice is carried only in stone and fossil. Yet, through the hands of those who dig, the eyes of those who scan, and the minds of those who simulate, that silence begins to speak. It speaks not in roars or thunder, but in data, in patterns, in truths slowly uncovered. And in that whisper from deep time, modern science finds not just the memory of an ancient Earth, but a mirror reflecting the mysteries of its own. And still, the quest for the Jurassic is far from finished. Each new method of study becomes another lens, another key to unlock what seemed forever sealed. In the quiet halls of synchrotron laboratories, beams of X-rays, 1 billion times brighter than the sun, pass through fossils, revealing not only bone but the chemical shadows of blood, vessels, traces of pigments, even whispers of soft tissue long since These ghostly signatures, invisible to the naked eye, speak of color patterns, of muscle density, of metabolic rhythms etched into the very atoms of stone. Suddenly, the image of a dinosaur is no longer a gray skeleton on a museum floor, but a vibrant creature whose skin may have shimmered in earthy tones, whose feathers may have carried patterns used for camouflage or courtship. The veil between life and rock thins, if only for a moment. Biomechanics adds yet another layer of resurrection. Through computer simulations, scientists animate digital skeletons, letting virtual muscles contract and bones pivot as they once did. They test how a sauropod's neck could reach across forests, how a pterosaur's wings might have folded against the wind, how the footsteps of a theropod struck the ground with a rhythm that echoed across plains. Each movement becomes a hypothesis, each stride a calculation, each leap a data-driven act of imagination. In these models, researchers discover the hidden efficiencies of evolution, how massive animals sustained themselves, how predators chased prey without collapsing under their own weight, how life engineered solutions that human architects still study in awe. Meanwhile, the chemistry of fossils speaks in isotopes, subtle ratios of carbon, oxygen, and nitrogen that remain locked within mineralized remains. By analyzing these patterns, scientists glimpse the diets of creatures that have not walked the earth for 150 million years. They can tell whether a dinosaur fed on conifers or cycads, whether a marine reptile hunted near the coast or in the open sea, whether climate shifts altered food chains across entire ecosystems. Isotopes trace the flow of energy through vanished landscapes, mapping the invisible threads that connect predator to prey, forest to herbivore, ocean to sky. In this way, the chemistry of stone becomes the diary of an ancient Earth, and yet, for all this precision, the effort remains tinged with philosophy. What does it mean to reconstruct a world that no human being will ever see? Perhaps the draw lies not only in science, but in memory, a memory older than humanity itself, a longing to understand the deep past from which all life descends. The Jurassic is not simply a chapter in prehistory. It is a mirror that reflects the fragility and resilience of existence. It asks questions that reach beyond paleontology. How does life endure change? What paths were never taken because of a single asteroid's fall? Could the age of giants have lasted to this day, had fate not intervened? Modern science, in its ceaseless reach, does more than answer. It keeps the questions alive. The fossils in desert sands, the scans in digital vaults, the models on glowing screens, all are fragments of a dialogue between past and present. Humanity does not awaken the dinosaurs in flesh, but it awakens them in understanding. And in doing so, it keeps alive the awe of an Earth that once thundered beneath footsteps larger than imagination itself. For the story of the Jurassic is not merely about creatures long extinct. It is about the human need to listen to a silence so deep, so ancient, that when it speaks at last through stone and science, it feels like a revelation whispered from the very bones of time. Beneath the slow turning of the earth, beneath the cycles of oceans and the quiet drift of continents, lies a truth that the Jurassic whispers to us. Nothing endures forever. Continents split and collide, climates rise and fall, life flourishes, and then vanishes. The Jurassic, once a living theatre of thunderous footsteps and emerald forests, now exists only in stone and memory. It stands as a reminder that every age, no matter how vast, is but a passing chapter in the longer story of Earth. Dinosaurs, once masters of the world, were not spared this law of impermanence. Their reign stretched across millions of years, longer than all of human history multiplied many times over, and yet even they fell. The planet continued, indifferent, reshaping itself for what would come next. In this light, the dinosaurs become more than ancient animals. They are metaphors for our own fragile sovereignty. Humanity walks today with the confidence of rulers, reshaping landscapes, altering climates, and building monuments to permanence. Yet deep time humbles such illusions. Against the backdrop of 4.5 billion years, the span of civilization is a heartbeat, and the presence of our species itself a fleeting spark. What are empires, nations, or technologies compared to forests that once stretched from pole, to oceans teeming with leviathans, to skies darkened by wings wider than our homes? The Jurassic reminds us that no reign is eternal, that even the mighty can vanish into silence. To contemplate deep time is to confront a vertigo of perspective. Every fossil is a fragment of that abyss, a whisper from an age so distant that language falters in its description. These bones, petrified and silent, are not merely remains. They are poetry in stone. They speak of lives once lived, of ecosystems vast and complex, of worlds utterly alien to our own. They remind us that we, too, will one day be but tracers. Our cities reduced to ruins, our species a line in future geology. perhaps to be discovered by beings who will find us as strange as we find the dinosaurs. This reflection is not meant to diminish humanity, but to place it within the greater fabric of existence. For there is a kind of reverence in knowing that Earth itself is the true protagonist, a restless and living planet that has worn many faces. The Jurassic was one such face, a moment of verdant abundance, of colossal creatures and unbroken forests of seas alive with forms both familiar and alien. Today, the Earth wears another face, shaped by ice and human hands, by the migrations of birds and the hum of machines. Tomorrow it will change again. One day, far into the future, Earth will appear as strange to its inheritors as the Jurassic does to us. Its mountains will be new, its climates unrecognizable, its oceans shifted into unfamiliar shores. Perhaps another intelligence will walk its surface and look upon the remnants of our age with the same wonder and disbelief with which we gaze upon the fossils of the sauropods. They, too, will feel the pull of deep time, the humbling knowledge that their moment is but one more chapter in the story of a restless world. The Jurassic, then, is not only an age of giants, it is a mirror held against us. It reminds us that Earth is alive, ever-changing, and profoundly mysterious. It asks us to listen, to see beyond the span of human years, to recognize that we are part of something far greater, something that stretches beyond imagination. In the silence of fossils, in the whisper of stone, in the endless turning of the planet itself, there is a lesson. Worlds rise, worlds fall, and yet the story continues, and in that continuity lies both our humility and our hope in the shadow of deep time. The Jurassic becomes more than a prehistoric curiosity. It becomes a meditation on impermanence itself. Every bone unearthed from the rock, every fossil leaf pressed into stone, is a reminder that worlds vanish, yet their echoes endure. The forests that once blanketed Pangaea's broken fragments are gone, their roots dissolved into dust, their trunks crushed beneath the weight of uncounted centuries. The thunder of sauropod herds has long since faded, replaced by winds that sweep across deserts and oceans. And yet, in their absence, something profound lingers, the awareness that the Earth itself remembers. For the ground beneath our feet is not inert. It is a palimpsest of histories, each age writing over the last, yet never fully erasing what came before. Walk through a quarry in China, a windswept plateau in Patagonia, or the cliffs of Morocco, and one treads upon the remains of vanished ecosystems layered into stone. The Jurassic is still there, hidden in the strata, waiting to be uncovered, waiting to remind us that the Earth we know today is not permanent. Our forests, our seas, our cities, all will one day join the fossils as remnants of a time that was. This realization unsettles, but it also awakens a deeper reverence, for to live is to stand within a fleeting moment of a far greater story. Dinosaurs, in their grandeur, serve as a paradoxical mirror. They were both fragile and eternal. Fragile, because they too fell to extinction. Eternal, because their legacy endures in the flight of birds. The curve of bones, the genetic echoes carried within living creatures. Humanity, too, is suspended between fragility and endurance. We craft monuments, launch machines into the void, record our languages and dreams, yet even these may crumble. Against the horizon of millions of years, the greatest works of human civilization may vanish as completely as the tracks of sauropods washed away in ancient rains. What, then, becomes of meaning? The answer, perhaps, lies not in permanence, but in participation. The dinosaurs did not endure, yet they shaped the earth profoundly. They sculpted ecosystems, seeded evolutionary lineages, left imprints that resonate still. Their story did not end with their disappearance. It transformed into something new. Humanity may follow a similar path. We may not endure as rulers of this world, but the mark we leave, whether in the DNA of species we have altered, the geology of a warming climate, or the relics sent beyond Earth, will ripple across time in ways unseen. In this, there is a strange comfort. Permanence is not required for significance. The poetry of fossils teaches this lesson with haunting clarity. Each fossil is a fragment, incomplete, broken, yet in those fragments lies enough to conjure entire worlds. A single feather trapped in stone evokes skies filled with creatures that no human eye has seen. A tooth, sharp and serrated, recalls the hunger of predators long turned to dust. A seed, preserved in amber, whispers of forests humming with unseen life. These are not mere curiosities. They are reminders that time itself is a sculptor, preserving fragments of memory, erasing the rest, leaving only enough for us to wonder. And it is wonder that binds us most deeply to the Jurassic. For when humans gaze upon the bones of a long-dead creature, there is both recognition and alienation. Recognition because we share the same earth, the same cycles of birth and death, the same struggle for survival. Alienation because their world was utterly other, a realm of strange climates, of titanic bodies, of rhythms foreign to our own. To contemplate the Jurassic is to stand at the edge of comprehension, to peer into an abyss of time where imagination strains against the vastness of reality. But perhaps the most humbling reflection is this: Earth will change again. The continents are still drifting, the climate still shifting, the biosphere still evolving. The age of humanity is but a moment, and the planet's story is far from finished. One day, in a future beyond our reckoning, beings unknown may sift through the remnants of our cities as we sift through the bones of dinosaurs. They may ask the same questions we ask. Who were they? What was their world like? Why did they vanish? In that symmetry lies a profound continuity, a reminder that all life is bound by the same cycles of emergence and erasure. The Jurassic was not merely an age of giants. It was a testament to Earth's restlessness, to its endless creativity, to the truth that life adapts, transforms, and eventually yields. And so, when we reflect upon that vanished world, we are not only looking backward, we are also glimpsing a mirror of our own fate. The lesson is clear, though veiled in mystery. Nothing lasts, yet everything leaves traces. To live in awareness of this is not despair, but reverence. For to be part of Earth's great unfolding story, even for a fleeting moment, is to belong to something vast, eternal, and profoundly beautiful. The fossils whisper this truth. Worlds rise, worlds fall, but the story of life endures, and as we listen, we are reminded that we, too, are only passing through, travelers upon a planet that will outlast us, shaping and reshaping itself in ways we cannot yet imagine.